Welcome back to eCoreAcademy, everyone. My name is Anita Raj, and I am one of the co-founders and teachers here, along with my younger brother, AJ Raj. In this new Algebra 2 lesson, we're going to be diving into the next section of our unit on polynomials. In this section, we're going to be focusing on dividing polynomials. So in this lesson, specifically in this video, we're going to be doing polynomial long division, and I'll be showing you what that is exactly. In the next video, we'll be doing synthetic division, and I'm thinking about doing a third video on some practice problems in which we look at word problems specifically in this that pertain to this section to help you, especially when you get those kinds of problems on your assessments. So in this lesson, we're going to be using long division to divide a polynomial dividend of degree 2 or higher by a polynomial divisor to determine the quotient polynomial and if the divisor is a factor. So we're going to be going over what long division is again. It's a skill that we all learned in elementary school probably, but in this case, instead of having your basic multi-digit numbers such as 5, 25, 4900, I'm just listing off random numbers, instead we're going to be having polynomials. So like x squared minus x minus 6 or x cubed plus 4x minus 6 or those kinds of polynomials, and we're going to be performing the same operation but with polynomials. We're going to have a dividend, and then we're going to have, and the dividend's usually going to be a quadratic, which is degree 2 or higher, so cubic, quartic, quintic, always be higher than that. And then we'll have a polynomial divisor. Usually it's a divisor with just two terms. It can be a linear factor, it can be a quadratic factor, and it can go on. Usually it'll just have two terms though, and we'll divide that factor into the polynomial, and we do that so that we can determine two things. We can determine one, if there is no remainder left, then that factor is a factor of the dividend. The divisor is a factor of the dividend. And if so, then we're going to find what the quotient is. Which the quotient polynomial resulting is. So before I dive into this video, there are two things I want to do. I just wanted to quickly show you this little image I have. It says, I don't like long division. I always feel bad for the remainders. You're going to see in the examples that we do what happens to the remainders. Remainders are what's left over. So you can always think of remainders as being the ones that are left out or excluded. So that's what this image is supposed to nod at. And before I get into the lesson, I'd really appreciate it if you all could like the video, subscribe, hit the post notification bell, drop a comment down below, and share using our socials. Let's get right into the video. So here's an overview of what I'd like to cover in the lesson and help you understand going into the next two lessons of this section. Here are some key concepts that I want you to keep in mind as you go through this lesson. First, our goal in this lesson is to divide polynomials using long division. And if you're wondering what long division is the process of dividing multi-digit numbers by hand. So for example, you'll usually see long division set up like this. I'm trying to think of a good example. How about this? 12 into 144. So literally another way of writing 144 divided by 12. Well, because these are multi-digit numbers, meaning they are numbers with multiple digits. So 12 has 2 digits, 144 has 3 digits. What we can do is we can set this up. If in case we haven't memorized our times tables, which are just mostly single digits, if we have multi-digits, we can set it up like this, and then we can divide 12 into 144 to find what the quotient would be. So it's the process of dividing multi-digit numbers, and we can do it by hand. So we don't need a calculator to help us. We can just do it by hand. So long division involves a divisor, a dividend, and quotient. Any kind of division is going to involve that. Remember, division is one of the four main operations in math. You got addition, subtraction, multiplication, and division. In division, you're going to have a divisor. The divisor is what you are going to be splitting the whole into. So it's going to be how many parts you're splitting a number into. It's going to be how many times a number goes into another number. So for example, if I have 5 friends and I'm trying to divide by 1, if I want to split those 5 friends by 1, like if I do 5 divided by 1, it's going to be 5, because you can make, if you have those 5 friends, you're trying to make groups of 1, you divide by 1, you're going to have 5 different groups because it's one person per group. That's what a divisor is. It's trying to split into groups. Dividend is what is being divided or split apart by the divisor. So in the scenario I just said, if you have a group of 5 friends and you're trying to divide them into groups of 1, the dividend is what you're dividing, what's being divided. So the 5 representing the 5 friends is the dividend, and then the quotient is what results. So if you divide the dividend by the divisor, whatever is left is the quotient, And if the divisor is a factor of the dividend, that means it'll evenly go into the dividend without any remainders, meaning the quotient times the divisor should give you the dividend, meaning the quotient and the divisor should be factors of the dividend. Sometimes you're going to have a remainder as well. A remainder is pretty much what's just left over. For example, if I had a group of 5 friends, that same 5 friends, but I wanted to split those 5 friends into groups of 2, so pairs. Well, I can split friend 1 and 2 together. I can put friend 3 and 4 together, but then friend 5 is going to be left by himself, herself, or herself. So in that case, we have a remainder of 1 because that one person doesn't make a complete group. So in this example, if we do 12 into 144, the 12 here is going to be the divisor. It's what we're splitting the dividend by, so it's the divisor. 144 is what's getting divided, so it is going to be the dividend. And I know my times table, so I know that 144 divided by 12 is just going to be equal to 12. That's just a perfect square. So in this case, 12 is going to be the quotient because it's what results. Quotient. Okay. Moving on. Whoops, I wrote right over example. Let me erase this. So here's an example for you. In this example, we're going to be doing example with basic long division. So we're not going to jump right into polynomial long division yet. We're literally just going to take two multi-digit numbers, 674 and 21, and just review how to do this basic process we learned. So here's your solution already pre-written if I'm dividing 674 by 21, and we're going to go through that again. So I'm going to just rewrite 674 divided by 21 as 21 into 674. We draw this like division symbol. I don't even know what the actual name of it is, but we use this little symbol here when we're doing calculations by hand. All right, so first what we want to do is we want to see how many times 21 is going to go into 64, because since this is a 2-digit divisor, we're going to look at the first 2 digits of the dividend. In this case, 21 can go into 64 3 times. So 3 times 21 is going to be equal to 63. Minus, if you subtract those two, you're going to get 4. And we're going to bring the 4 here down. So 44. So 21 into 44 is going to be 2 times. 2 times 21 is going to be equal to 42. So if I subtract 42, I'm going to get 2. And if you see, we've run out of numbers because 674, we've used up all the digits. What we do in this case is we go into decimals. So in this case, we would have a remainder of 2. So we could technically write this as 32 remainder 2. But if you want to keep going, you can actually find the decimal equivalent of that. So what I can do is I can actually add another 0 to the end of this 20. And I'll put a decimal point right here. So whenever you add a 0 to the remainder, you're going to put a decimal point to indicate that you're going into the decimals. So if I add a 20 here, if I add a 0 here, I have 20, but 21 can't go into 20 at all. So what I do is I add my first 0 up here, and if I add a 0 up here, that means I can add another 0 to the end of this number, so I get 200. 21 can go into 200. It can go 9 times. 9 times 21 is equal to 189, so if we subtract that, we're going to get 11. And we're going to add another 0 to the end here because we're not done yet, because 21 can't go into 11, but 21 can go into 110 evenly. It can go 5 times. 5 times 21 is going to give you a perfect 110. If you subtract those, you get a remainder of 0. And when you get a remainder of 0, you're all done. So your final answer is going to be 32.095. And that was just a quick review of long division for you. All right, so let's look at long division with our first problem. Here's your problem. Divide the given polynomials. The two polynomials you're given are 3x squared minus 29x plus 56, and the second one you're given is x minus 7. So the first one is a quadratic trinomial, and the second one is a linear binomial. You're dividing the first one by the second one. So the first one's going to be your, I'm going to write it underneath it. This is going to be your dividend, and this is going to be your divisor. So divisor. Here's how you're going to do it. This is going to be your solution. I figured that the best way to show you how to do polynomial long division is just to do a bunch of examples with all of you. And that's probably going to be the easiest way for you all to learn, rather than me try to walk through specific steps, because every scenario is different. If you have long division with basic numbers down, you should be perfectly fine with this. All right, so that's the solution pre-written. I'm going to run through that exact same scenario with you. So we're going to, just like we had that little division bar thing, we're going to set that up, and we're going to put our divisor on the outside. In this case, our divisor is x minus 7. So we're going to write x minus 7 on the outside, and then on the inside, we're going to write our dividend as we usually did. So that was 3x squared 3x squared minus 29x plus 56. So we're going to treat these as though they were those numbers we were just working with without any variables in them, although these are polynomials, so they are different. The first thing we're going to do is we are going to look at the first term of our dividend, which is x. And we're going to look at the first term of our divisor, which is 3x squared. What we want to focus on is the x squared. We are pretty much trying to see what do we have to multiply x by so that it can go into 3x squared. It can get as close as possible to 3x squared. So what are we trying to multiply x by to see how close it can get to 3x squared? In this case, we have to multiply it times a 3 if we want to get to 3x squared, and we have to multiply it times another x to get it to the x squared. So technically, x times 3x is going to give you 3x squared. So 3x is what we have to multiply x by. Therefore, what we're going to do is we're going to write 3x over at the top, which is where our quotient would go. So we're actually starting to write out our quotient. So we're going to write 3x at the top, and notice how I didn't put it right over 3x squared, because if you look at the degrees of the x's here, this x is a squared, this x is linear because it's just 1, and this x is x to the 0, which is equal to 1 because this is a constant term. So because we're multiplying 3x times x to get this 3x squared, we're going to put the 3x over the term of the dividend that has the same degree, that is of the same degree. So this is going to be your linear term of the dividend. So you're going to put the linear term of the quotient above it. That's why I put the 3x over the negative 29x. So then what we do is we do 3x times this whole expression, x minus 7. So 3x times x is going to give you 3x squared. And then 3x times negative 7, don't forget this part. You have to multiply the 3x times the negative 7. That's going to give you a negative 21x. What you're going to do is you're going to take this whole expression here, and you're going to subtract it from the 3x squared minus 29x. You can ignore the 56 for now. So what you're going to do is, and recall what we did was we did 3x times x minus 7 to get this expression here. So 3x squared minus 3x squared is just going to cancel out, which is what you want. You want the first term to always cancel out. So these guys are going to cancel out. Negative 1 times negative 21x is going to make this a positive 21. So negative 29x plus 21x is going to give you a negative 8x. Then what we do is we want to bring this 56 down. So we're going to bring this 56 down here. And what we do is we literally do the exact same thing. So we look at the first term of our divisor, which is x, and we look at the first term of what we have down here, which is negative 8x. So what do we have to multiply x by to get negative 8x? Well, we don't have to multiply it by any x's because these x's are both linear terms, so they're both literally the same. However, we got to multiply x times negative 8 to get negative 8x. So I'm going to write negative 8x up here where my quotient is. I'm going to write it above the 56 because the negative 8 and the 56 are both constant terms. Then I'm going to multiply negative 8 times x minus 7. And then what I'm going to end up getting is negative 8 times x is going to be negative 8x. And then negative 8 times negative 7 is going to be plus 56. And then I'm going to subtract this expression from the one I had up there. And what happens is negative times negative 8x is positive. So negative 8x plus 8x is going to cancel out. 56 minus 56 is going to also be equal to 0. So we're going to end up getting 0. And what the 0 represents is the remainder. In this case, there is no remainder, which is ideal in all situations. So in this case, since we don't have a remainder, this is going to be our answer. So if we divide them, this is going to be our quotient, our final answer. All right, so let's move on to the next problem. This is a long division problem number 2. I'm going to pick up the pace a little bit because I do want to get through more problems, and hopefully you get the process by now. So here's the problem. So the question's asking us, is the first polynomial a factor of the second? The first polynomial, which is going to be your divisor, is x to the 4th minus 1. And then the second polynomial, which is going to be your dividend, is going to be p of x is equal to x to the 5th plus 5x to the 4th minus x minus 5. So they're asking, is the first polynomial a factor of the second? So they're pretty much asking, is the divisor going to evenly go into the dividend without having any remainder? That means that it's going to be a perfect factor of the dividend. So here we're going to look at the solution. I know it looks kind of long, and I want to show you what's special about this problem. So what we first want to do is we want to set up our little division, our long division. So we have our divisor on the outside, so I'm going to write x to the 4th. However, we're not just going to jump to the negative 1. What's going to happen is, if you see, this x to the fourth minus 1 is skipping a bunch of terms. It's skipping the x cubed term, the x squared term, and the x term. And when we do long division, we have to account for all of those. So in this case, they don't exist. Either they canceled out or we just don't have them. In this case, we just have the quartic term and we have the constant term. We don't have the cubic, the quadratic, or the linear term, if you recall perfect polynomial standard form. In that case, we have to fill them in. So x to the fourth plus 0x cubed, because technically we don't even have an x cubed in our factor, so it's almost like you got to make it up. So you have to throw a 0 in front of it, because this indicates that it's not part of the actual divisor, but you have to also account for the 0 for the x cubed term. So then we do the same thing with the quadratic, so 0x squared plus 0x, and then you throw the minus 1 at the end, and we're going to divide this into x to the fifth plus 5x to the fourth. However, if you realize this is missing a cubic term, an x to the third, so we're going to fill that in with a 0x cubed. It's also missing a quadratic term, which is x squared, so we're going to fill in a 0x squared, but it has a linear term, so negative x minus 5. So that's the special thing about this problem that I just want you to keep in mind. You're going to have to do this when doing long division. So now what we have to do is we're going to look at the x to the fourth, and we're going to look at the first term here, which is x to the fifth. Well, to get x to the fourth to equal x to the fifth, we got to multiply x to the fourth by x. So x is going to be the first part of our answer. So I'm going to put x over negative x, because these are two linear terms. We're not going to put x over x to the fifth, because this is a quintic term and this is a linear term. We want to put the linear term over the linear term. So now what we want to do is we want to do x times this whole expression here. So x to the fourth plus 0x cubed plus 0x squared plus 0x minus 1. So if we multiply this all out, we're going to end up getting x times x to the fourth is x to the fifth. If we multiply x times any of these zeros, x times 0 is just going to be equal to, if we multiply x times each of these, it's going to raise the degree by 1. So x times 0, x cubed is going to give us 0x to the fourth, because x cubed times x is going to equal x to the fourth. X times 0x squared is going to give us 0x cubed. X times 0x is just going to give us 0x squared. And then x times negative 1 is just going to give us negative x. And we're going to subtract this. For now, we're just going to ignore that negative 5 at the end, because we're going to drop it down later. So if we subtract x to the fifth from x to the fifth, it cancels out. 5x to the fourth minus 0x to the fourth is just going to give us 5x to the fourth. 0x cubed minus 0x cubed is just going to give us 0x cubed. 0x squared minus 0x squared is just going to give us 0x squared. Negative x minus negative x is going to be negative x plus x, which is going to give us 0x. So that's what we have so far. What we want to do now is we want to drop this negative 5 down. I'm sorry I'm cramming at the end of the side of the screen, but we're dropping the negative 5 down. Now we want to look at what we have here. So we have the 5x to the fourth. We're going to return to our divisor, which is x to the fourth. To get it to 5x to the fourth, well, x to the fourth and x to the fourth are the same. We don't need to multiply by any x's, but we do have to multiply by 5. So we're going to end up having to add 5 to our quotient. So now what we're doing is we're going to multiply 5 to the whole divisor. So x to the fourth plus 0x cubed plus 0x squared plus 0x minus 1. So if we multiply 5 times all of that, we end up getting 5x to the fourth plus 0x cubed plus 0x squared plus 0x, and then 5 times negative 1 is negative 5. And remember, we're subtracting. So if we subtract 5x to the fourth, if we subtract 5x to the fourth from 5x to the fourth, we're going to get 0. And all of these zeros pretty much are just going to be equal to 0. And if we do negative 5 minus negative 5, we're doing negative 5 plus 5, which is going to give us 0. So at the end, this is going to be our quotient, but remember what the actual problem is asking. Is the first polynomial a factor of the second? Well, in this case, our remainder is equal to 0. So is it a factor? Well, it is a factor, because if the remainder is equal to 0, the divisor evenly divides into the dividend. So that means yes, the first polynomial is a factor of the second one. All right, let's move on to the next problem. So this is long division problem number 3. Here's the problem. is the first polynomial factor of the second. Your first one, which is your divisor, is x squared plus 1. Second one, which is your dividend, is p of x is equal to 3x to the fourth minus 4x cubed plus 12x squared plus 5. Here's your solution pre-written for you. It's a bit longer, but you're going to see that this is a bit of a different scenario, and I did want to go through this one to show you something. All right, so we're going to write our divisor first. Our divisor is going to be x squared. We don't have, notice how we have x squared, but we jump immediately to the constant term, so we got to add that linear term, plus 0x plus 1. And our dividend is going to be 3x to the fourth minus 4x cubed plus 12x squared. Notice how we don't have a linear term, so we have to add 0x, and then we're going to have a plus 5 at the end. So what we're going to do is we're just going to do the exact same thing we did on the last problem. So how many times does x squared go to 3x to the fourth? Well, you have to multiply x squared times another x squared to get x to the fourth, and you have to also multiply by 3. So we're going to end up having to multiply by 3x squared. So I'm going to put that over the 12x squared because they're both quadratic. 3x squared times x squared plus 0x plus 1 is going to end up giving us 3x to the fourth plus 0x cubed plus 3x squared. If we just multiply that out, we're subtracting this whole expression. So negative 3x to the fourth minus 3x to the fourth is be 0. Negative 4x cubed minus 0x cubed is just going to be negative 4x cubed. And then 12x squared minus 3x squared is going to give us plus 9x squared. We're going to drop the 0x down, which is the linear term. Now we're going to see how many times can x squared go to negative 4x cubed. Well, we have to multiply by negative 4. We also have to multiply by another x to get x times x squared to equal x cubed. So now what we're going to do is we're going to do negative 4x times our divisor, which is x squared plus 0x plus 1. And if we multiply that all out, we're going to end up getting negative 4x cubed plus 0x squared minus 4x. And if we subtract that, negative 4x cubed minus negative 4x cubed is going to be negative 4x cubed plus 4x cubed. That's just going to be 0. 9x squared minus 0x squared is just going to give us 9x squared. We're going to get 0x minus negative 4x, which is going to be positive 4x. And then what we want to do last is we want to drop this 5 down here. And we're going to get plus 5. Yeah, plus 5. We want to look at this x squared and this 9x squared. We have to multiply x squared by 9 to get 9x squared. So we're going to add a 9 to our quotient. 9, and then we're going to distribute 9 to this divisor, x squared plus 0x plus 1. And then what we're going to do is if we multiply this all out, we're going to get 9x squared plus 0x plus 9. We subtract that. We end up getting the 9x squareds cancel out. 4x minus 0x is going to give us 4x. And then 5 minus 9 is going to give us negative 4. However, if we look at our factor, our first term is x squared, and our first term here is 4x. X squared cannot go into 4x because the x here is linear, the x here is quadratic. That just doesn't work because x squared is already higher than x. So in this case, if we look at it, there is a remainder. So our remainder does not equal 0, meaning there is a remainder. Our remainder is 4x minus 4. If there is a remainder, that means this is not a factor. The divisor is not a factor. So the answer to the original question would be no. So no, the divisor is not a factor of the dividend. All right, let's move on to the next problem. These last two problems are going to be pretty similar. We're pretty much just going to be finding the quotient. So here's the problem. Divide the given polynomials. So we're dividing 6x cubed plus 11x squared minus 4x minus 9, which is going to be a cubic polynomial of 4 terms, which is going to be our dividend. We're dividing that by 3x minus 2, which is our linear binomial, which is going to be our divisor. And so here is our solution pre-written for you. As you see, there's something different in the quotient. I'm not going to tell you exactly what it is, but it's a bit different from what we've been doing. If you look at the end, and I'll show you exactly what that means as we walk through this problem. All right, so what we're going to do is we're going to write our divisor, as always, outside of our little division hut or house, you want to call it. Then we're going to write our dividend inside, 6x cubed plus 11x squared minus 4x minus 9. And then I'm going to draw the little roof here for our quotient. Now we're going to look at 3x and 6x cubed. 3x can go into 6x cubed. Well, 3 can go into 6 2 times. X can go to x cubed 2 times. So 3x times 2x squared is going to give us 6x cubed. So I'm going to write 2x squared over the 11x squared because they're both quadratic. And if we multiply 2x squared times 3x minus 2, we're going to get the expression 6x cubed minus 4x squared. So we can subtract this expression from 6x cubed plus 11x squared, and the 6's are going to cancel out. 11x squared minus negative 4x squared is going to be 11x squared plus 4x squared, which is going to be 15x squared. And we're going to drop the negative 4x down. So if we do that, we're going to compare 3x to 15x squared. We got to multiply by 5, and we've got to multiply by another x. So we're going to have to add plus 5x to the top. If we multiply 5x times the expression 3x minus 2, we end up getting the new expression 15x squared minus 10x. And we're going to subtract this. Subtract that. The 15's are going to cancel out. Negative 4 minus negative 10x is going to be negative 4 plus 10x, which is just going to be 6x. And we're going to drop that final negative 9, that constant term, from the dividend down. 3x goes into 6x. That's pretty simple. That's just 2 times. So we're going to add plus 2. And we're going to multiply 2 times the expression 3x minus 2. If you distribute that, you'll end up getting 2 times 3x is 6x. 2 times negative 2 is negative 4. And if you subtract that expression from 6x minus 9, the 6x's are going to cancel out. Negative 9 minus negative 4 is just going to be equal to negative 9 plus 4, so you're going to get negative 5. You're going to end up getting negative 5 for that. So this is going to be our remainder, because if you see 3x cannot go into negative 5 because negative 5 is constant, doesn't even have an x term, so that doesn't evenly divide. So negative 5 is going to be our remainder. In this case, when we have a remainder, we're going to actually write it as part of the quotient. So we're going to write our negative 5, but we're going to write it as a fraction. So we're going to put our negative 5, but for our denominator, we're going to take our divisor. So we're going to put 3x minus 2 as our divisor. So think about this. Whatever your remainder is, whether it be like 4x minus 4, like in the last example, or in this case, negative 5, you're going to add it to the end of your quotient. So negative 5 is going to be the numerator, and then your denominator is going to be the divisor you were originally given. So in this case, it was 3x minus 2. And this is going to be our final example. If you don't get that, don't worry. We're going to do it again in the next example. So this is practice problem number 5 with long division of polynomials. Here's your problem. Divide the given polynomials. Our dividend is x to the 4th minus x cubed minus 9 plus 21x minus 15x squared. As you can see, it's not in perfect descending order, so we got to rearrange it so that we have quartic, cubic, quadratic, linear, and then constant, divided by 3x minus 4 plus x squared. That's going to be our divisor. It's also not in perfect descending order, so we got to rearrange that before we divide. Remember, it has to be in perfect descending order, and every term has to be accounted for. Like that example where we had all those zeros, 0x cubed, 0x squared, 0x, all of the terms from the leading term to the last term have to be accounted for. So this is going to be your solution. I'm going to walk through that again with you. So in this case, our divisor is x squared, 3x minus 4 plus x squared. We're going to put x squared at the front because it's our leading term. Then we're going to put 3x after it because it's the linear. And then we're going to put negative 4, which is the constant at the end. So that's going to be our divisor. In our little dividend or division little house thing, I don't know what you want to call it, we're going to put x to the 4th first because that is the highest degree. Then we're going to put the negative x cubed after it because that's the second highest. Then we look for a quadratic. We have one, which is negative 15x squared, Then we're going to look for a linear, which is 21x. And then finally our constant, which is negative 9. So we just rearrange that really fast before we're doing long division. Now we want to compare x squared to x to the 4th. Well, x squared goes into x to the 4th twice, so we're going to have x squared. X squared times x squared is x to the 4th. So we're going to multiply x squared times x squared plus 3x minus 4. If we multiply to get that together, we get the expression x to the 4th plus 3x squared minus 4x squared. And if we subtract those, you end up getting the x to the 4th cancel out. You end up getting negative 4x squared negative 4x cubed. I should have written this as a 3x cubed. Sorry, that's a 3x cubed. You end up getting negative 4x cubed minus 11x squared plus 21x, because we're going to drop the 21x from the dividend down. Now we're going to compare x squared to negative 4x cubed. Well, we have to have a negative 4 because that's going to be our coefficient. And then we got to have an x because x times x squared is going to give us the x cubed. So I'm going to write the negative 4x over 21x. If we multiply negative 4x times x squared plus 3x minus 4, we end up getting the expression negative 4x cubed minus 12x squared plus 16x. And if we subtract that, the negative 4x cubes cancel out, negative 11x squared plus 12x squared is going to give you a positive x squared, and 21x minus 16x is going to give you plus 5x. Lastly, we're going to drop the negative 9 down from the dividend, which is going to be our linear term, and we're going to compare x squared to x squared. Well, x squared can only go into x squared once, so we're going to have a plus 1. If we multiply 1 times our divisor, which is x squared plus 3x minus 4, we end up getting the expression x squared plus 3x minus 4, because 1 times anything can just be equal to whatever you multiplied it by. Finally, if we just subtract these two, the x squareds are going to cancel out. 5x minus 3x is going to be 2x, and negative 9 minus negative 4 is just 9 plus 4, which is going to be, 9 minus 4, negative 9 minus negative 4 is negative 9 plus 4, which is going to be negative 5. Whew. This is going to be a remainder because x squared cannot go into x anymore, so this is going to be a remainder. So what we're going to do is I'm going to rewrite the quotient, which is what we have so far. This is the quotient we have so far, x squared minus 4x plus 5. I just took it from the top. And I'm going to take the remainder, which is going to be plus 2x minus 5. Remember, your remainder is going to be your numerator. And I'm going to put it over our divisor, which is going to be our denominator. And this here is going to be your final answers. So remainder is going to be your numerator, and divisor is going to be your denominator, and you just tag that on to the end of the quotient whenever you do have a remainder. If you don't have a remainder, if it's just 0, you don't have to worry about that. You can just write the quotient. In this case, if we didn't have a remainder, we could have just written x squared minus 4x plus 1, but because we had that remainder, we had to account for it, so we tagged it along to the end. And that's all I have for you today. I hope you enjoyed that lesson. It was nice to run through that. It gives me it gives me some nostalgia about last year when I was learning about this topic. So I do hope you enjoyed. And look out for the next video on synthetic division. If you did enjoy, please like, subscribe, hit the post notification bell, share using our socials, and drop a comment down below. Check out our website and Gmail as well. Thank you, and see you in the next Algebra 2 lesson.